All right, so we're going to start out with a fairly basic example so we can just see how this is all going to work. So we have a system here, and we are going to do the solution method of solving by graphing. So our system is x plus y is equal to 0, and y equals -1/2 x plus 1. So looking at this, first, some observations that I want to make are that I have two different formats of equations. I have this top equation in standard form, and this bottom equation in slope-intercept form. Now we know with slope-intercept form, it's perfect. It's super conducive for graphing. We know that we don't need to do any extra work to make this graph very easily. If I look at this standard form equation though, I need to do a little bit of work. I can either put this equation into slope-intercept form and graph it that way, or I can actually find the intercepts by doing that like hand method of saying like, okay, I want to know what the x-intercept is, so I'm going to make y equal 0. I want to know what the y-intercept is, so I'm going to make x equal to 0. And I can figure out the intercepts and graph it that way. It doesn't matter which one you do. I do find though with systems of equations with graphing, it's kind of nice to have them written in slope-intercept form because it's sometimes one of those things where you see the rise over the run and then suddenly you're hitting the point and you see it happen really quickly. Whereas if you graph using intercepts, which again is totally fine and a super doable way to graph. I feel like when I graph with intercepts, I'm not quite seeing the solution very easily. And I like sort of discovering the solution. I like seeing it. So I'll show you what I mean. I'm going to first graph this one, because this second equation, because it's already in slope-intercept form. I don't have to do any extra work. So I'm going to start with my y-intercept of 1. And then it looks like my slope is -1/2. So that means from this 1, I'm going to go down 1 to the right 2 to get that negative slope, down 1 to the right 2 to get the negative slope, down 1 to the right 2 to get the negative slope. I can even move it backwards and go up 1 and to the left 2, up 1 and to the left 2, and I can start to formulate this line. So I now have this line here graphed. I'm going to turn this equation now into slope-intercept form. So if I have x plus y is equal to 0, I'm going to subtract x from both sides to get y all by itself. So I get y is equal to -x plus 0, technically. Now, we don't need to have that there, but it helps me graph my y-intercept and being very conscious of where it's at. So I have this 0 here, and now I'm going to graph my slope of -1. -1 written in slope rise over run form would be -1/1. So I'm going to take from this y-intercept, I'm going to go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. And as I go, I am seeing that my line, this line is getting further and further away from the other one that I graphed. So that means I need to work myself backwards a little bit to see if I can find the intersection point. So from this 0, 0 point, I'm going to now go up 1 to the left 1, up 1 to the left 1. Do you see what I mean? Now I am graphing these points, and I actually, like when I graphed, I literally saw the point where it intersects. And it was awesome. It's cool. Like when I graph using slope-intercept form, I can really see the lines sort of come together. Whereas if I were to do this with intercepts, I would find that my intercepts are actually 0, 0, meaning my x and y intercepts are at one point. So I'd have to use slope-intercept form to graph this anyways. Now, that's not always going to be the case with the standard form equation. Usually you will find more intercepts. You'll find both an x and a y. There'll be different numbers or different points. But that being said, graphing it with slope-intercept form is really nice to sort of see how the graph sort of develops, and you can sort of play around with how a line is moving away versus towards another line. Either way, for this system of equations, I've just found the solution. Solution, again, is where it intersects. So the intersection is right there. The intersection is right there, and that point is -2, +2. So my intersection, or the solution, is -2, 2. So I can say that the solution is just that point. Cool? Isn't that neat? So I'm going to do a couple more, or I'm going to do at least one more graph in the next video. And this one's going to be a little bit more complicated, mainly because it's not necessarily going to fit super nicely on my graph paper. So we're going to have to play around with it. And then after that, you can start working on the must-do practice problems. Thanks for watching. Bye.